All right, 8.2. Linear equations in two variables. Okay. Basically, we've talked about linear equations with one variable. Okay. Let me give you an example of one of those. That would be like 3x plus 4 equal 20. Okay. That's a linear equation in one variable. Okay. Today, what we're going to talk about is linear equations in two variables. Okay. So, for example, if we had 2x plus y equal 10. Okay, so this is a linear equation with one variable. Okay, this is a linear equation in two variables. Okay, now, where you're going to see, what we're going to be doing this, and pretty much in this whole chapter, is talking about lines, graphing lines, and the equation of lines. For example, if we have a graph, once again, coordinate plane, and we have a line like that graphed in that coordinate plane, okay, there is an associated equation that goes with that line. Okay. That particular one's probably going to be close to y equal probably 2x plus 3. Okay. And I'll explain how I came up with that in later sections, but that's what we're talking about. That's the kind of line that we're talking about. The reason it has to have two variables is because of this. Every point that we put on that line has two coordinates. It has an x value and a y value. Okay? For example, right here, that's probably 0, 3. Okay? It has an x coordinate, 0, and a y coordinate, 3. So, for us to be able to graph that line or have an equation of that line, we've got to have an equation that has two variables in it. Okay? Now, there are linear equations that only have one variable that you can graph. Okay? Usually they're a horizontal or a vertical line. Okay? Not all the time, but usually. So, that's what an equation with two variables looks like, what we're going to do with it. Okay? So they're going to take you through a step-by-step process of here's a two-variable equation, here's one way to find solutions for it. Okay? Then here's another way to find solutions for it. And then here's the final way to find solutions. So we're going to talk about three different ways that you can come up with solutions for that equation. Okay? There's going to be multiple solutions to that equation. All right? There's not going to just be one answer. It's not going to be a nice y equal 4 or x equal 2 like we've been doing in the past. Okay? You're going to have an ordered pair for that problem. Now, let me give you an example of this first way that we're going to look at things. They give us the expression or the equation y equal 2x. I just lost it. Where did it go? Okay, let's erase that. 3x plus minus 5y equal negative 1. Okay, 3x minus 5y equal negative 1. What they want to do is this. They're going to put right beside it two numbers. They're going to put 9 and 5 in parentheses. So this That is the ordered pair. Okay? That is our x and our y coordinates of a certain point. What they want to know is does that point at 9 and 5 lie on the line that is represented by 3x minus 5y equal 1? Okay, that's what they're basically asking us. The actual question is the ordered pair a solution of the equation? That's the actual question that they're wanting you to answer. Okay, but what they're really wanting to know is if we graph this line, is that point 9, 5 going to be on that line? The way we do it is we plug those coordinates into the equation. So we're going to plug in the 9 right there for the x. We're going to plug in the 5 right there for the y. So our equation would be this: 3 times 9 minus 5 times 5 is equal to negative 1. Okay, now we work it out. Well, what is 3 times 9? 27. Minus, what's 5 times 5? 25 equal 1. What is 27 minus 25? 2. Is 2 equal to negative 1? No. So the answer here is no. That is not a solution. It's not going to fall on the line that's represented by 3x minus 5y equal 1. Okay? Okay. Now, that's one way to do it. Okay? The second way to come up with the solutions, number 2, let me go ahead and put this number 1 right here. Number 1 was is to check solutions that are given. That's number 1. Number 2 is graph the equation. Okay, if you don't have graph paper, I would highly suggest getting some. I'll try to get some copied up and give to you before you leave today. But you're going to need it for this chapter. This chapter has a lot of graphing and stuff in it, so you'll need to have some graph paper. It's not going to, it's not necessarily going to where you can't draw your own on a little, on your notebook paper, but it'd just be easier and take you less time if you had the graph paper. So they want us to graph this. Okay, they want us to graph an equation that they're giving us. Okay, for example, they want us to graph y equal 2x minus 3. Now I'm going to change my graph here, graph paper. Now, how do we do that? Okay, well, what they want you to do is basically this. They want you to do an input-output table. Okay? Now, let's remember back to Section 1. Remember in Section 1, we had our input-output table. And what did we have? We had x and y, correct? Okay. Well, that's what they're wanting you to do here. They're wanting you to take and make an input-output table for this equation, y equal 2x minus 3. So what they want you to do is this. I'm going to take and make an input-output table. And I'm going to put four values, 1, 2, 3, 4. I'm going to put 4 values on this table. Okay, now, you can come up with any domain that you want to come up with, or input values. Okay? It does not matter. What I would suggest, though, is don't do like 22, 25, 27, because then your graph's going to be huge. What I would do is this. I would just simply go, okay, 0, 2, 4, and 6. Those are my input values. Okay? Just you're basically making them up. Well, I'll tell you here in a second. Yes, for the most part, especially if the number in front of your variable is a whole number. If it's not a whole number, it's a fraction. We'll do one here in a second. It's got a fraction in it. There's a certain requirement I would say do. Real personally, I probably wouldn't use 0, 2, 4, and 6 all the time because, like, for example, in this one, looks like you're going to end up having an output value that has like a 9 or a 12, and so it just means your graph's got to be larger. Okay, so you could use if you felt comfortable with negatives, the easiest way to do it is do like I'll give you an alternate pair here, like -2, 0, 2, 4. You could do something like that, or you could do -1, 0, 1, 2, 3. The reason I'm skipping 0 to 2 is because I don't want all three of my points right here in just a small little area, because then it's harder to draw the line. Because I'll tell you why here in just a second. Let's finish it up here. So what I'm going to do is I'm just going to plug in that 0 for my x. Y is equal to 2 times 0 minus 3. Well, what is 2 times 0? 0. So I have y is equal to 0 minus 3, which means y is equal to -3. Does anybody not understand why it's -3? Okay, so that goes in my y output. Okay, then do what? So if you go 0, if I'm at 0 on the number line and I subtract 3 from it, I've got to go left. Okay, the other reason, the mathematical reason, is because this is 0 plus -3, because we got to change all subtraction to addition. So that's why 0 plus -3 is what the actual problem says. Okay? All right, now the 2. My pen never acts up in any other class except y'all's. For real. Yeah, I never have any problems with it except for this class. Hey. That's you're going to recognize that one. All right. Y is equal to 2 times 2 minus 3. Okay, well that's y is equal to 4 minus 3. 4 minus 3 is what? 1. So that's y equal to 1. So my output value when x is equal to 2 is 1. Now I plug in the 4. 2 times 4 minus 3. 2 times 4 is what? 8 minus 3.
5.
Y is equal to 5.
I thought you changed all subtraction to.
You do. 8 plus -3 is still 5.
Oh, yeah.
Then the last one, y is equal to 2 times 6 minus 3. That would be y is equal to 12 minus 3, which y is equal to 9. Okay? Now, we have to graph that. Okay? So that means I have to draw a graph down here. Okay, our first one was 0 and what? -3? So I'm going to plot 0 and -3. There's 0 and -3. My next one was 2 and 1. So 2 and 1 is right there. Next point was 4 and 5.
Yeah. How do you know where to put these?
Huh?
How do you know where to put these?
What do you mean, how do I know where to put these?
Where the little dots? How do you know? Count. 1, 2. Count. I'm so sorry. I thought it was
1, 2, 1, 2, 1. We've had this 3 years in a row now. We've already had it this year.
Well, the dots were already there.
No, they weren't. We regraphed dots. The next one is 4 and 5. So 1, 2, 3, 4, and go up 5. 1, 2, 3, 4, 5. So that's 4 and 5. And then the last one is 6 and 9. So that's 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's 6 and 9. Now, when you draw the line through that, so that's the answer. Now, once again, all of you are could have possibly different answers, with the exception of your line has still got to look like that. In other words, let's say I used these figures. Let's say I used -1. You don't have to copy this down. Let's say I use -1, 0, and 1 as my domain. Okay, so I plug in y equal 2 times -1 minus 3. Well, 2 times -1 is 2 times -1 is -2 plus, let me do it this way, minus 3. Well, -2 minus 3 is plus -3, so -1 and -5 is that ordered pair. Now, listen to me. I really need you to focus, okay? Or you'll be focusing in somebody else's office. Got me? -1 and -5 would mean I have -1, then 1, 2, 3, 4, 5. So even with me drawing a crooked line, it still would have fallen on that dot. So it doesn't matter if I choose those values, -1, 0, and 1. Okay, we already did 0. We already know that 0 is right here. We already know that 1 is right here. Okay, so it doesn't matter if I would have chose those 3 points, the 4 points that I chose, doesn't matter. They're still, if you draw your line properly, are all going to fall on that line. Okay, so it doesn't matter which ones you choose. They will all eventually give you the same line. Now, what the question is they want you to answer is this equation a function? That's what they want you to answer. Well, when we were talking about graphing things the other day, we said that the vertical line test tells us whether it's a function. Well, is that line vertical? Does it go straight up and down? No. So yes, this is a function. So this and that are both the answer to that problem. Okay? Once again, I could have picked any of the numbers I wanted to start the problem. I just chose those just to pull some random ones out. And realistically, you really only need to do 3 points. You don't have to do 4. I did 4 to give you a better example of how you plug them into the equation, and then once we've got the answers, how we graph them on the coordinate plane. Gracie?
Wait, so do we have to do both? Or do we have to do that one? Or like, you said there's 2 of them?
No, that's the second way, but the directions tell you to do it by graphing, because they didn't give you. The only way you can do this is because the only thing they gave you in the problem is that. They don't give you any numbers to test with it. They don't. So the only thing you can do is graph that. Okay, so you have to graph it. Okay, there's a third way that we're going to talk about in just a few seconds. I'm going to do another one of those, make sure we've got this one down. But there's another way it's called function form, that we're going to show you here in a second. Okay? All right, so if I do another one, okay, let's look at these two first. Let's say they give us the equation there. That's the equation. Okay? Well, does it have two variables? No, it only has one. Okay? So, what they want to know is, they want to know, where is X? Copeland, come here. I want you to show me where X is equal to 3 on the screen. Where is X equal to 3? Okay, so right there. That's where X is equal to 3. Okay, yes, you may go back to your chair. Thank you. Now, X, right here at that point, what is the coordinates of that point I just circled? Copeland. 3, 1. Okay. What is the coordinates of the gray point? 3, 2. So I could keep going up, or I could go down. This is 3, -1. This is 3, -2. 3, -3. So in all these cases, isn't X, the X coordinate, equal to 3? Correct?
Yes.
Okay, so what kind of line do I have if I connect all those dots? Vertical. This is a vertical line. That is the graph of X equal 3. Now, so is that a function?
Yeah.
No. Because you can draw a vertical line and hit more than 2 of the dots.
Wait, I thought it's like the 3, like if there's 2 3s that equal like a number, then it's automatically a function.
No. If there's more than 1 3 as an input, they would all have to equal the same number.
Oh.
So it'd have to be 3, 1, have a 3 down here, 3, 1, have a 3 down here, 3, 1. If they don't, in other words, if I did these values on an input-output table, you would have this right here. You'd have X, Y, you'd have 3, 2, 3, 1, 3, 0, 3, -1, 3, -2. So all the inputs have a different output. So therefore, that can't be true. Yeah, you had it backwards. So the answer to this one is
No.
Yes.
No.
the answer to that is no. Now, Okay, now look at number 21. Number 21 says y is equal to negative 5. Okay.
Does this need a graph?
So, where y is equal to negative 5. So they want to know where the y coordinate is always equal to negative 5. Well, negative 5 would be 1, 2, 3, 4 would be right there. Okay, that's 0, negative 5. Okay, well also, this point right there is negative 5. That's 2, negative 5. There, that's 4, negative 5. That's 6, negative 5. Okay, well all of them are still equal to negative 5, correct? So if I connect all of those with a line, you have a horizontal line. Okay, so therefore this would be a function. Okay, so if it's y equal a number, then it is a function every time. If it is x equal a number, it is not a function. It is a vertical line. And this is a horizontal line. Okay? So those are the two types of different graphings of lines. Now, okay, for tonight, we'll finish this up tomorrow. We're going to do 8.2, and we're going to do 3 through 23. We'll talk about function form and a couple other things tomorrow. Okay? You may go.